the principle of mathematical induction. Step 1. And if you look at my handout I gave you with the example with 15 points, it'll go step by step what you have to write and how many points it's worth. So step 1 says you want to show S sub 1 is true. So let's go ahead and do that with this particular problem. And I just use a bubble 1. And what you want to do is you want to show S sub 1 is true. So that's worth 1 point to just write the statement out. So what is S sub 1? You want to use a colon here. And to show S sub 1 is true, there's a left side and a right side. The first term is 1, right? The first term is 1. And on the right side, n would be 1. So 1 equals 1. And we're going to use some new notation. This is a triangle of dots, which in mathematics stands for therefore. Therefore, S sub 1 is true. So if you look at my point sheet, you've just earned 4 points. Okay? Step 2. You need to assume S sub k is true, then show S sub k plus 1 is true. And what we want to do is we want to know what's our goal. And you can put your goal somewhere off to the side. And I'm going to have a problem here in a moment because my screen is not nearly big enough. So I'm going to put my goal up here. My goal is to show that S sub k plus 1, if I were to plug it into this top row, on the right-hand side, I want to show that I would replace the n with k plus 1, and it would be k plus 1 squared. Okay? So right now, we have S sub n equals 1 plus 3 plus 5 plus 7 up to the nth term is 2n minus 1, and it equals n squared. So what this is, and this actually connects beautifully to our arithmetic and geometric sequences that we did. On the left side, you see here is the sum of the terms, and this is what the nth one looks like. Do you remember how we would do a sub n and we did our DNA? This is like the nth term, but on the right side, if I just plugged in and I added those together, so I did the series, the sum would equal n squared. Now think about this a minute. If I wanted the sum of the first 2 terms, that would be S sub 2. S sub 2 would be 1 plus 3, which is 4. Isn't that 2 squared? How about S sub 3? If I looked at S sub 3, that's 1 plus 3 plus 5. That's 9. But isn't that 3 squared? Okay? So on the left side, this is either going to be an arithmetic or geometric series that I'm adding together, and the right side tells me how to quickly add them together. All right. So here's my goal. So if I wanted like the 10 sums, S sub 10, you would end up with 10 squared. Okay? So in step 2, assume S sub k is true. Well, what does S sub k look like? And when you're doing a formal proof in mathematics, you really do. It seems a little silly to students to have to write some of this out. They're like, well, all you're doing is changing the n to a k. Well, when you do a proof in math, you can't assume anything unless you have stated it in your proof. Okay? So I'm going to state what S sub k is. It's 1 plus 3 plus 5 plus 7 up to 2k minus 1, and it equals k squared. Now, I need to look at S sub k plus 1. I'm trying to show S sub k plus 1 is true. So what I need you to do on this first one is just try to stay with me. I don't expect you to really understand it all yet. Okay, but just sort of write down and just try to stay with me. On the second one, we'll try to develop a little bit more of you comprehending it. So here we go. If I want to go S sub k plus 1, I'm going to do S sub k and then I need to go one more term. So for example, because I know we struggled with this with our recursive formulas, where we did a sub k is 5 plus a sub k minus 1. So I know some of us were struggling with the abstract concepts, and this is going very abstractly now. If I want the next term, you replace k with k plus 1. And you may not write down equals k plus 1 squared. That's what we're trying to prove. So all I can do is add the next term in the list. So what I know then is if I add up the first k, isn't that equal to s sub k? I do know that because it's right in the line above it. 1 plus 3 plus 5 plus 7 up to 2k minus 1. We defined it in our work, and that's why we're allowed to use it, is s sub k. Then this next term is 2k plus 1. Because if I distribute, and we're pre-calc students, so we should be able to do this part in our head, that's 2k plus 2 minus 1. That's 2k plus 1. Now, I'm going to go ahead and continue this over here. I'll switch colors, just knowing where I am. And what do you know about s sub k? Is there something we wrote down in our proof that we know about s sub k? What else is it equal to? It's k squared. So let's substitute for s sub k, what it's equal to, which we wrote down right here, is k squared plus 2k plus 1. Hey, wait a minute. Isn't k squared plus 2k plus 1, k plus 1 the quantity squared? My pen is acting up here. Sorry about that.
Maybe you need to calibrate.
There we go. K plus 1 squared. Uh-oh, isn't that what our goal was? We've just shown that s sub k plus 1 is k plus 1 squared. So, therefore, we're going to use the triangle dots. Therefore, s sub k plus 1 is true. Now, what we want to do is you're going to make sort of a bigger triangle of dots and say, by steps 1 and 2, and PMI, PMI stands for the principle of mathematical induction, S sub n is true, and we're going to use a new notation here. It's an upside down capital A. That stands for all n greater than or equal to 1. Okay, so you're going to do step 1, show s sub 1 is true, and do it. Step 2, you assume s sub k is true and show s sub k plus 1 is true. That's what we want to do. Somewhere you need to write your goal down by replacing on the right-hand side the n with a k plus 1. Show that. Then the very last thing you do is you need to say, okay, I did step 1, step 2, which is the principle of mathematical induction. Then I know it's going to be true for all n greater than or equal to 1. Yeah?
In step 2, when you added the next term,
Yes.
do you always replace k with k plus 1?
Yes, because that's the next one in the list.
Oh, that makes sense.
It's always the next one in the list. Okay, so at this point, I just need you to make sure you've written all the steps down.
What's PMI do again?
Look at the top of your paper, Kara. What does it say at the top? So you can figure it out. There you go. Okay, so here we go. Let's try example 2. It says prove s sub n equals 2 plus 6 plus 10 plus up to 4n minus 2 equals 2n squared. All right, here we go. Step 1. Show s sub 1 is true. So you're going to go through this process every time. So S sub 1, use a colon. The first term is 2. On the right-hand side, if I replace the n with a 1, I would have 2 times 1 squared. So 2 equals 2. Therefore, S sub 1 is true. Step 2. Assume S sub k is true. We want to show S sub k plus 1 is true. Let me switch colors and we'll put our goal up here. Our goal is we want to show S sub k plus 1 is 2 times k plus 1, the quantity squared. So somewhere you have to place your goal and know that that's what you're targeting. That's what you're trying to get to. Okay? So again, step 1, show S sub 1 is true. Then you're going to make a conclusion. The triangle dots means therefore S sub 1 is true. Step 2, assume S sub k is true, and we want to show S sub k plus 1 is true. After you write your second step, that's where you want to state your goal. Yeah.
What happens if f sub 1 is not true?
Then you can't prove it by mathematical induction. Yeah. If you would get to S sub 1 and it didn't work, then you can't prove it with this method.
Will we have some like that at all?
No, I would not, because the objective here is we're going to prove them by mathematical induction. So if you're plugging in and it's not working, you've made some kind of mistake.
Okay.
Yeah, my intention is not to trick you or anything like that. Okay, so here we go. If we're going to assume S sub k is true, we need to state what S sub k looks like. And that is very simply go up to S sub n and replace the n with a k. All right, now we're trying to prove that S sub k plus 1 is true. So you work with the left side and then get it to turn into the goal that we bubbled. So here we go. To find S sub k plus 1, and Chase had asked an excellent question. She said, do you always replace the k with a k plus 1? And the answer is yes. You take your left-hand side of S sub k, rewrite it, and add one additional term where you replace k with a k plus 1. That's the next one. Okay? So now watch. And it really is going to be the same process every single time. Your manipulation will change, how to make it turn into your goal, but it's going to be the same setup, the same process. So 2 plus 6 plus 10 plus 4k minus 2, I put in a different bracket here. What does that equal to? S sub k plus, and let's try to do the mental combining like terms. That'll be 4k and then what? Plus 2. Excellent. Okay, excellent. Now, I heard somebody was ahead of us already. S sub k is 2k squared. And do you guys remember earlier in the year when we were proving our trig identities, and I told you when you prove a trig identity, you have a brick wall and you can't cross the brick wall. You can work the left side, you can work the right side, but you can't like add to both sides of that equation. Well, doing this is similar in that when you look at your goal, you want to keep peeking at the goal. I'm trying to get 2 times the quantity k plus 1 squared. That's a tip-off that I should have a GCF of 2, right? Okay, well you look here, we have a 2. Yeah?
If I just like don't do like the first step, but I know it's 2k, and I just like, is it okay to just?
No, you need to do this so I know you understand that you are substituting for S sub k. You do, yeah, I don't want you to jump right here. Okay? This is a formal proof, and in a formal proof, we're putting like every step in that we're doing. Okay, excellent question. All right, then k squared plus 2k plus 1, I've met the goal. Therefore, S sub k plus 1 is true. So this is really rather fun. I mean, this is one of the reasons why I love doing this, is that you're actually doing something very challenging, and we're able to do it piece by piece. Okay, so we're going to write by steps 1, 2, and the principle of mathematical induction. S sub n is true for all n greater than or equal to 1. Because the principle of mathematical induction says if you do step 1 and step 2, then you have proven that that statement is true. Okay? So, and this is excellent for those of you going into AP Calculus. We have to do a lot of justifying our answers for the AP Calculus exam. And this will really, really help.
This is not here. Just
Yes.
to make sure I have it right. The upside down A means all.
For all.
For all.
Yes, the upside down capital A symbol stands for all. For all. All right, hey, we're going to get the third one in. Yay. Okay, here we go. It says prove S sub n is 1 plus 4 plus 7 plus up to 3n minus 2 equals n times the quantity 3n minus 1 over 2. So here we go. Step 1. Show S sub 1 is true. So S sub 1 equals 1 times 3 minus 1 over 2. Therefore, S sub 1 is true.
Mrs. McInerney,
Yes.
is this stuff going to be on our final exam?
Yes, for seniors, this will be your very last topic on your final. Step 2. I'm sorry, I don't know why my pen is doing this. Very jagged. All right, assume S sub k is true. And you want to show S sub k plus 1 is true. After you write that statement down, you want to put your goal somewhere.
So that means we have, like, when we do our cheat sheet, we just have to write the steps, not the.
You can't do an example.
Yes, so
Write down
you
the
show the
words.
steps, but
Yes.
not the example.
Yes.
Okay.
We can just write down the words that we'll have to put down.
So the goal here is we want S sub k plus 1. Can somebody describe the goal? Is anybody getting the hang of this already that feels like they could really tell us what the goal is? Kara?
K plus 1 times 3k plus 2.
Oh, excellent. Okay, I'm going to put one little step in here because you did a great job with that. So initially what you do is this, and then it is absolutely fine to simplify it because that'll be 3k plus 2. Yeah, nice. Okay, nice job. Because you really are replacing the n with a k plus 1. And Kara went ahead and already did the simplification there. 3k plus 3 minus 1 would be 3k plus 2. And do you see that that one is a better expression to deal with to try to get it to look like the second one instead of the first one there? All right, here we go. So S sub k, 1 plus 4 plus 7 plus up to 3k minus 2 equals k times 3k minus 1 over 2. And so we have to state this because if we're going to use it, it has to be in the proof somewhere. All right, S sub k plus 1 just means I write down S sub k and then I go one more term. So you do want to identify that the first k terms does in fact represent S sub k. And then that next term would be what? 3k plus 1. Then S sub k was k times 3k minus 1 over 2. Now we need to somehow manipulate this so that it looks like our goal. When you look at your goal, can you see that it had a common denominator of 2? I don't have a common denominator of 2 right now, but I can build a common denominator of 2 by multiplying by 2 over 2. Okay? So then this gives me 3k squared minus k plus 6k plus 2 all over 2. Do you see what I did there? I multiplied out my numerators and put it over the common denominator. So then that's 3k squared plus 5k plus 2 over 2. And I would love it, I tried to give you in the notes on your pages like a lot of space. I would like you to flow down the page. Unfortunately on my screen I'm going to have to draw arrows over, but since you have enough space, please flow down the page. It just looks really nice that way. So then if you peek over at your goal, doesn't that numerator factor into k plus 1 times 3k plus 2? Therefore, S sub k plus 1 is true. Then the last step, by steps 1, 2, and the principle of mathematical induction, S sub n is true for all n greater than or equal to 1.